Yeah. Then can you read again what you wrote? Soft magnetic material.
Magnetic materials which are preserving their magnetism for a short period of time bracket they lose their magnetism once the conditions are removed.
Are called soft magnetic materials.
Are called soft magnetic materials.
Example: iron. Then iron alloys.
Example iron alloys.
Etc.
So what more materials are soft magnetic materials?
No more, no more. That's it. Only iron.
Only
Iron
this.
is soft magnetic. Other things are hard magnetic material. Then hard magnetic material you give
um, Hard magnetic
yeah.
materials.
Yes. You make the definition
Yes.
hard magnetic material.
Okay. Magnetic materials which are preserving their magnetism for a long period of time bracket they do not lose magnetism once the conditions are removed are called hard magnetic materials. Example
Nickel, cobalt, steel, etc. Huh?
nickel, cobalt, steel, etc. Sir, if it is nickel alloys, so it will be a hard magnetic material.
Yes, yes. Nickel, cobalt, alloys are also hard magnetic material.
Okay.
Then we have also uh, another one that is stainless steel. Huh? Though it's not that much discussed in O-level syllabus, but in IGCSE syllabus, there is, lots of discussions on stainless steel. Stainless steel is non-magnetic material. Okay,
Hmm. Non-magnetic. Okay.
stainless steel is non-magnetic material. It's even not a magnetic material. It's neither hard nor soft. It's non-magnetic material. So uh, there is place of where you wrote about non-magnetic material. There you can also write stainless steel.
Hmm.
Okay, now we have um, induced magnetism. Okay, induced magnetism.
Right.
Induced
Induced
magnetism Induced magnetism means if if a magnetic material
If a
magnetic material
magnetic material
is
is
brought
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 inside
inside a magnetic field,
a magnetic field,
then it behaves like a magnet,
then it behaves like
like
a
a magnet.
magnet.
That's why uh, that's why this that's why we call it as induced magnet.
Hmm.
And the process is called induced magnetism.
Okay.
So in this case, you can draw one diagram from your book. Can you open Unit 21, page number 334?
Hmm.
334, you see, there is magnetic induction, right?
Yes, it's saying yes.
So you see, permanent magnet brought near to soft iron bar. Huh? Soft iron bar becomes
Hmm.
an induced magnet. Okay, so this diagram you draw, huh?
Okay.
Figure 21.8, that is more appropriate to draw it. Huh?
So should I draw both of them?
Yeah, you can draw both of them if you want to make your time, uh, save your time, then only 21.8.
Okay.
Because it's already in your book. So the one which one is more appropriate, that one is, make your notes shorter.
Hmm.
So induced magnetism, you understand, right?
Kind of.
And you also understand magnetic, non-magnetic, and magnetized materials. So magnetized means just now we got induced magnetism. So there we got one soft iron bar. That one was not magnet before. Now it is magnetized, right?
Hmm.
And the iron nail also. Those are also magnetized materials. So can you label iron nails? You drew already, right? Iron nails
Yes.
and induced magnets. So they are in both you label as magnetized materials. Magnetized materials.
Hmm. Sir, can you actually tell me what is actually induced magnetism? Like
Sorry.
briefly. Can you tell me what is induced magnetism briefly?
Induced magnetism means the material was not before magnet, but when you are bringing it inside a magnetic field, then it behaves like a magnet. That is called induced magnetism. Is it clear now?
Yes. So, sir, the induced magnet should be a soft magnetic material or hard magnetic material?
Both can be both. If it is
Uh,
soft, then it will lose its magnetism.
quickly.
But if it is hard magnetic material, it will not lose its magnetism. Once it is magnetized, it will preserve it. Okay.
Yes. Okay.
Okay. Then you uh, write methods of magnetization. Methods of magnetization. Write this.
Methods of magnetization.
Yes.
Magnetization.
Yeah. Go to page 336. Page 336. You see the first first method of uh, magnetization is number one, stroking.
Hmm.
You see what is called stroking in the diagram.
Yes, it's like
Okay.
banging.
Yes. So this type of uh, magnet we are making by stroking. Normally we are making permanent magnet. Okay, hard magnetic material.
Hmm.
Then second method is making a magnet electrically.
Sir, making a magnet by stroking. Is it like uh, we hit the magnet and then we pull it
Not
back?
heating, not heating. It's like stroking means friction. You are touching it, and you just rub it with the magnet. It's not heating.
Is it like
Rubbing,
putting and
rubbing,
then slide it, sliding back?
rubbing. It's like rubbing. You can say rubbing.
Okay.
Okay. Pulling means by touching, pulling means rubbing, right?
Hmm. Hmm.
And second method is making a magnet, making a magnet
Making
electrically.
a magnet electrically. Sir, should we learn the description given between making a magnet
Not,
by stroking?
not that much required now. I will let you know what you have to learn. Okay.
Okay.
So here we have making a magnet electrically, you just write it, huh? Then
Hmm.
you draw the diagram here. We have figure 21.17, that one.
21.17.
Yes, this
Yes.
one. This one is required here. So you have the circuit, positive, negative, and there is windings of wires, and that is called solenoid. Huh?
Wire.
Yes, you see the yellow color, huh?
Hmm.
Yellow color wires are there, very thin, is showing. You have to check it very carefully, huh?
Hmm.
So this is called solenoid, huh?
Hmm.
And it is uh, owned after, you see there is inside a soft magnetic material, there is iron inside it. Inside the solenoid there is soft magnetic material, iron. So once the electricity is going through it, the solenoid, then this iron becomes magnet, because due to the flow of current we have magnetic field produced over there according to right hand
Sir,
theory.
how did you get iron? It's given steel.
Okay, if you want to make a permanent magnet, then you have to give steel. Okay, if you want to
Hmm.
give temporary magnet, then you have to give iron.
Hmm.
Is it clear?
Yes. So if I want to make a permanent magnet, I put steel, and
Yes,
to make a temporary magnet, I put iron. Achha.
yes.
So should I draw this one?
Which one?
21.17.
Yes. 21.17 you have to draw.
Okay. Sir, what if the flow of current? I mean, like, what if the flow and current of was in like in opposite way, like from B to A? I mean, like from A to B.
Uh,
No, from B to A. Yeah, yeah, from B to A.
then the poles will be opposite.
Okay, okay.
If you change the direction of current, then the direction of poles will be also changed.
Okay.
You see, there is written right hand grip rule, figure 21.19.
Hmm.
So according to this rule, we can find the poles, where it will be north pole, where it will be south pole.
Hmm. Okay. So like the direction of my thumb is north.
Mhm. And the direction of other fingers is the direction of current flow.
Hmm. Hmm.
So method of magnetization done.
Hmm.
Now we have method of demagnetization. Page number 338.
Hmm.
So there are three methods written over there. Huh? You write all of them. Number one is heating. Number two is hammering. Number three is alternating current. During method of magnetization, the current we gave, the electricity we gave, that is direct current.
Okay.
Now for demagnetization, we need alternating current.
Sir, won't you explain each of them?
Yeah, direct current means the current direction is not changed. It's always going from positive to negative, right?
Okay.
And in alternating current, your positive side and negative side changes in 1 second 250 times. If the frequency is 250, okay?
Uh, Sir, I did not understand making a magnet electrically. Like, how does the current show that the poles is this make the poles?
Yeah, this is one property of uh, current. If the current is passing through a conductor, then it can also produce magnetic field. Okay, so using this property, when we are passing electricity through a conductor, then if we are having the magnetic field, then if you are bringing any magnetic material inside this magnetic field, we are getting actually induced magnetism. Are you
Okay.
clear now?
Hmm.
So in this way, we can get uh, the magnetism from electricity.
Hmm.
Now it's clear, right?
Hmm.
So you write methods of demagnetization, all three. Number one is heating, number two is hammering, number three is alternating current. And during alternating current, you should draw the diagram, figure 21.21.
Hmm.
Hmm. During demagnetization with alternating current, we have to slowly withdraw the magnet from the magnetic field or solenoid.
Sir, slowly withdraw the magnet. What does this mean?
Yeah, you have to do it slowly so that demagnetization process can work better. Otherwise, there will be still some magnetism.
Okay. So you have to like move it slowly.
Yes, yes. In a Cambridge questions also is coming. This slowly is very important. You will get it in past paper questions.
Hmm. So what means I want to draw that 21.21, right?
Yeah, 21.21, yes.
Yes, sir, done.
So you got the methods of demagnetization also. So we are done till D, right? We are done till D. Now we will go for
21.4. Yeah.
now
Oh
we
yeah,
will
D.
go for um temporary
Fields.
magnets, temporary magnets and permanent magnets. Okay, temporary
Yeah.
magnets. You give the heading that using soft magnetic material we get temporary magnets.
Yes, second repeat one more. Temporary
You
magnets.
temporary magnets give hyphen, then you write using soft magnetic material we get temporary magnets.
Second repeat once more. Sorry.
Yes, yes. Using soft magnetic material we get temporary magnets.
Using soft magnetic materials,
We can make temporary magnets.
you can make temporary magnets.
Magnets. So uses of temporary magnets. Uses of
Sir,
yes.
temporary magnets and soft magnetic materials, are they same?
Actually, soft magnetic materials, when they are made magnet, they are called temporary magnets. Until
Okay, okay.
until they are made magnet, they are only magnetic materials. They are not showing any property of magnets.
So temporary magnets and soft magnetic materials are the same thing.
Soft magnetic materials are used to make temporary magnets, but we cannot say 100% same because soft magnetic materials they don't have the property of magnets, right?
Hmm.
Once they are bringing inside the magnetic field, that time they are behaving like magnet, right?
Hmm.
So once they are behaving like magnet, then we are saying them temporary magnets.
Hmm.
So there is
So
little
the
bit,
materials are behaving like magnets. Yeah.
yes, yeah, temporary magnets. Soft magnetic materials are used to make temporary magnets.
Hmm.
So you see uses of soft magnetic, yeah, uses of temporary magnets.
Hmm.
You can go to page 343.
First, let me say uses of temporary magnets.
Yes,
Page number 341.
343.
Okay. Hmm.
You see, there are some uses of electromagnets. Electromagnets means this is temporary magnet. Okay, that means when once you are using electricity, they are they are working or they are behaving like magnet. Once you stop the electricity, they are like only soft magnetic material. Okay,
Hmm.
no more magnet. That's why they are called electromagnet. And you see some examples, some common uses of electromagnetic include number one, audio, video tapes. Then number two, other uses of electromagnets. We have electric bell, simple magnetic relay, the reed switch, the circuit breaker.
Yes, sir. Let me just write this one. So, sir, an electromagnet is a temporary magnet
Mhm.
which is done by giving electricity.
Yes, yes. It should be direct current, DC.
Audio and video tapes,
Then
the electric bell,
mm,
the simple magnetic relay, the reed switch, the circuit breaker.
so can you go to page number 347?
Yes.
You see here we have all the description of electric bell, simple magnetic relay, the reed switch, the circuit breaker. Okay,
Hmm.
we have brief discussion over there about all this. So you have any
Hmm.
questions from here?
Till how much I have written?
Yeah, this. Do you have idea about this before? Like
No.
relay, reed switch, electric bell, circuit breaker. You know about them, right? But reed switch, relay, do you know about them?
I don't know about relay and read, but I have an idea on circuit breaker and electric bell.
Yeah, relay means there are two circuits. One is small circuit, another one is big circuit. So a smaller circuit is used to operate bigger circuit. As one
Hmm.
circuit is used to run another circuit, this is called relay circuit. You know about relay race, right?
Yes.
There more than one athlete is working to finish the track, right? That is called relay race.
Hmm. Hmm.
Similar way, here we are having more than one circuit, and one circuit is helping other circuit to work. That's why it is called relay circuit. Okay. In
Yes, sir.
car we have relay circuit like with the key of the car we are starting a small circuit, and this small circuit is running a bigger circuit in engine, right? We are not
Yes.
directly giving the switch in the engine, rather here the small key is used to switch on here, then this circuit is working to run the bigger circuit. So this one is on relay circuit.
Hmm.
In nuclear power station also we are using relay circuit so that we do not need to go to the main part of the power station always. We can operate it from a remote place. Is it clear?
Yes.
So this type of circuit are called relay circuit. And now reed switch are the things which the switch work if a magnetic field is coming closer to the switch. Look, there is one switch inside a glass tube, right?
Hmm.
And terminal A, terminal B is there. They are made from iron, iron material, soft magnetic material. Okay.
Hmm.
So once a magnetic field is brought closer to this switch, what happens? This uh, iron terminals becomes magnetized, right?
Hmm.
And once they are becoming magnetized, they can attract each other and they are in contact. Once they are in
Hmm.
contact, the circuit is on.
Hmm.
So this type of switch is called relay switch. Yeah, reed switch.
Hmm.
Is it clear?
Yes. Hmm.
In laptop, you have sleep mode, right?
Yes.
So that sleep mode works using the reed switch.
Hmm.
Is it clear?
Like, how does it work in the laptop?
Yeah, that one is a very, big discussion. So
Oh.
just you write it that in laptop we are having sleeping mode working due to the reed switch. Okay,
Hmm.
just you are giving the example that where it is working reed switch. Now
Hmm.
we have we are done with temporary magnets, right? Examples,
Hmm.
uses. Now permanent magnets.
Hmm.
Okay, permanent magnets are made from hard magnetic materials.
Hmm.
And
So,
uses of
wait, I want to write this one. Yeah.
yeah, write it please.
It's a permanent magnet, right? Yeah.
Yeah, yeah.
Hmm.
So uh, we are getting permanent magnets from hard magnetic materials, right? We wrote
Hmm.
this. Now we have some uses of permanent magnets.
Wait, sir, using hard magnetic materials,
Okay, now you go to page
we get
342.
we can make wait a moment, permanent magnets. Hmm. 342. Hmm.
342, yeah. 342, you have some examples of permanent magnets. Number one, moving coil galvanometer.
Moving coil galvanometer. Hmm.
Yes. Then number two, magnetic door catch.
Magnetic door catch.
Then number three, other uses of permanent magnets. You see there are lots of example, huh? You
Uh,
can write all of them in short.
Moving coil loudspeaker. Hmm.
Yes, we are done with
Then
we are done with FG,
wait,
learning
sir,
of
I did not
concepts.
finish this.
You finished?
No, no, I can't write it in short. Like,
Okay.
how do I write that?
Yeah, only you write the things like uh,
DC motors, AC
DC
generators.
motors, AC generators. This way you write. Computer
One.
computer memory, huh? Then
Computer memory.
then uh, then for removing magnetic materials from patient eye, then moving coil loudspeaker.
Hmm.
Okay, that's it. Etc. You give etc. Lots of things you read. Then plotting compass.
Plotting compass. Hmm. So this is another use, right?
Yes. Another another heading you give magnetic field lines. Magnetic field lines.
Hmm. Yes, sir.
Number one,
Hmm.
field lines start from North Pole and into the South Pole.
Yes, sir.
Magnetic field lines never cross each other.
Yes, sir.
Magnetic field lines are closest at the poles. Magnetic field lines are closest at the poles. You wrote 3 points, right?
Yes.
Now you draw diagram 21.25.
Yes, sir.
So you got it right.
Hmm.
And magnetic field lines, how they are working.
Hmm.
And this diagram is related to plotting compass. So a compass is used to get the field lines here. Is it clear?
Yes.
And and also you can check page number 339. There is diagram 21.22. That one is also showing you field lines, but that is using iron filings.
Hmm.
Is it clear? In
Yes, sir.
iron filings, we are getting the shape of the field lines, but we are not getting the direction. But in
Hmm.
plotting compass, we are getting also the direction. Is it clear? Now,
Yes.
now you check. You do not need to draw. You just have a look on page 340. We have two more diagrams here. Diagram diagram 21.26. You see
Hmm.
how the repulsion field are working. Do you understand?
Yes.
The field lines due to repulsion. And here also you understand that magnetic field lines are coming out of North Pole, right?
Hmm.
Again, figure 21.27, we see the North Pole and South Pole of two different magnets, how they are working. Okay, the field lines, how they are working. And also on on figure 21.28, we have two two separate magnets. They are placed one above another one. If they are keeping two north poles in the same side, what is happening? If they are keeping north and south pole in other sides, what is happening? Is
Hmm.
it clear?
Yes.
Okay, very good. Now,
Sir, can I draw this too?
yes, which one? You do not
21.23.
need to draw. It's fine. You will understand it because the basic thing, if you know, then you just remember that magnetic field lines are coming out from north and it's going into the south. If you can remember this, you can find anyone. Is it clear?
Yes.
That's it. You do not need to draw all of this. Just you understood it. That's it. Just remember what I said. The next
Sir.
one is, you see, we are also done with till G. We are done. Then we are also done with K, isn't it?
Yes.
Now we have J. J J is also little bit discussed. Just we had the idea about the solenoid, how the right hand grip rule is working. That one is related to J. Okay, so we are now going with that one. You give the heading, the pattern of the magnetic field due to currents.
Uh, the pattern of the the pattern of the magnetic field
Yeah, magnetic field due to current. This one is your
due to
heading. Now you go to page number 344.
hmm,
You see there is one diagram 21.39. Can you draw this diagram?
Yes.
And during drawing, you should be aware about one thing, that is, you see, we have the current direction upwards, right? Straight wire. So the
Current
magnetic
direction
field,
upward.
yeah, you see here there is one small arrow in blue color wire. Can you see it?
Oh, yeah, yeah.
And so it is a direction of current. You see current I, and there is field lines produced, magnetic field lines produced in red color, and it is
Hmm.
anti-clockwise. You see, if you are following the right hand grip rule, your thumb is upwards, then your other fingers are working anti-clockwise, right?
Yes.
And there is another point you have to remember this. You see the red lines coming from the center, which are very close to center. They are closer to each other. But the
Sir,
more you are
sir,
going
can,
far away,
sir, wait. Sir, can you repeat from the beginning a bit?
yes, yes, sure. Look, the direction of current is clear to you, right? It's going
Upwards,
upwards.
yes. Upward.
Then your thumb is upwards. Then your other fingers, if you are making right hand grip, then other fingers
Yes.
are showing the direction of magnetic field lines. Is
Hmm.
it clear?
Yes.
Then your magnetic field lines, when you are drawing with red color, you see at the center the field lines are very close, right? The
Hmm.
more we are going with far away, the field lines gap are more. Do
Hmm.
you do you see it in the diagram?
Yes.
So
Sir, what do you mean by we are when we are going far away?
that means in the center there is one circle. Then after that there is another circle. So the circles are moving away, right?
Hmm.
So from the
Yes.
center it is far away. Uh, the far away the field lines, we have bigger gap.
Hmm.
Why the bigger gap? Because the field lines are, magnetic field lines are becoming weaker. The more it's go away from the center.
Hmm.
The more closer the field lines, the more stronger the magnetic field. Is
Hmm.
it clear?
Yes.
Okay.
Hmm.
So you during your drawing you should be very careful about this. So you draw now figure 21.39. The gap should be
Okay.
maintained. The gap should be maintained clearly, correctly.
Sir, can you tell me one more time why the field lines is becoming bigger? I mean, like further away from each other.
Because the more closer the field lines, the more
To the
stronger
current.
the magnetic field.
To the current.
Is it
Like
clear?
the more closer to the center. I mean, to the
Yes,
magnet,
yes,
to the
yes,
current.
yes. If the field lines are more closer, then the magnetic field is stronger. You had also this idea before, right? Uh, in our magnetic field lines properties, you got that magnetic field lines are closest at the poles, right?
Hmm.
So if the magnetic field lines are closest at the poles, that means at the poles the magnetic field are more stronger.
Hmm.
You can see also this one on. Can you go to page number 332?
Yes, sir.
332 and also 331. The first diagram, you see, iron filings are accumulated at the poles most, right? Page number
Hmm.
331. Can you go?
Yes, I went.
Yeah, there you see at the poles the iron filings are accumulated more. That means at the poles the field lines are strongest.
Hmm.
Then again you go to page number 332.
Hmm.
You see at the poles the pins are accumulated more.
Hmm.
So where the field lines are closer, there is stronger magnetic field.
Yes.
Is it clear now?
Hmm.
Does it make sense
Yes. Yes.
and make you confident, right?
Hmm.
Okay, now the one we are discussing that is done.
Yes.
21.39 the figure. That one is done.
Yes. Yeah, I do it.
Are you doing or it is done?
Yes, sir. I've drawn.
Okay, very good. Now you go to page number 346. 346
Hmm.
you see at the top magnetic field pattern of a solenoid.
Hmm.
You have
Hmm.
figure 21.43. Draw this one.
Hmm. Okay.
Oh,
Yes, sir, done.
Okay, you are done with uh, this one, J.
Yes, sir, but what does this symbol in the right and left mean?
Which one?
Like S and Z, green color,
Where?
in figure 21.43.
Okay, that one is actually showing you how it is north, how it is south. Yeah, you see, in north it is anti-clockwise, right?
Hmm.
And south it is clockwise.
Hmm.
So it depends. You see how the field lines are coming out. They are
Hmm.
taking that point.
Hmm. Okay.
You do not need to go for that one. Just you think that the way the current is going inside. Okay, the direction of current, and you follow that one. Just at the beginning, you got the idea. Right hand grip rule. The thumb will be north. Okay,
Hmm.
thumb will be
Hmm.
north, and the other fingers are showing you the direction of current. That's it.
Hmm. Okay.
That one will make your understand easier.
Hmm.
Okay, done.
Yes.
Now magnetic spinning. For some delicate instruments like very uh,
The magnetic spinning.
yes,
Like
the heading is
spinning or
magnetic
spinning.
screening.
Oh.
Written there. You don't see the sharing.
Oh yeah, I just did not see it in it.
Yeah, we are talking about H now. We are done with all. Now only left H and I.
Hmm.
Okay, magnetic screening. Magnetic screening. First you understand, then you write it. Huh? So we are now
Yes.
going for discussion with this. For example, we have a very delicate electronics equipment like it can be clock, hmm,
So
or
it can be
it can be clock, small clock, huh?
clocked.
Yeah, or any electronics, small equipments are there which are working inside some sophisticated electronics equipment. Okay, there are
Hmm.
some circuits. If they are come closer to any magnetic field, then their function will be, you know, disabled, or their function will be interrupted.
Hmm.
Got it? So
Hmm.
for this type of electronic equipments, what we are doing, we are keeping them inside a iron box. This type of iron box, we are keeping them. This iron box is made in a way this way. Huh? So you know that in iron, the domains or the small magnets, You know, all the magnetic materials, they have tiny magnets, right, in their structure.
Wait a second, just start from the beginning.
Yeah, yeah,
Uh, Lost you.
yeah. You see, for the delicate instruments which are
Hmm.
prone to magnetic field, they are affected by magnetic field. If their function will be disabled or their function will be interrupted, for
Hmm.
them we are using iron box, okay,
Hmm.
to preserve them. Why?
Hmm.
So that if there is any magnetic field is coming, those magnetic fields lines are going this way, channels, okay,
Hmm.
for channeling the magnetic field lines this way
Hmm.
around the iron box. Iron box has tiny holes, sorry, tiny domains, right? You know, in iron,
So what is domains?
domain means all the magnetic materials. For example, you are given copper, that is metal, and aluminum, this is metal, but they are not behaving like magnetic materials. However, iron, steel, nickel, cobalt, they are behaving like magnetic materials. Why? Because in iron, nickel, cobalt, steel, all they have small magnets inside their structure. Okay,
Hmm.
and those all tiny magnet, they have all north and south. You see,
Hmm.
this one, the black color is north and the white color is south. Huh? So this way we have lots of tiny magnets inside the structure of magnetic materials. They are normally they are not arranged. They are not
Hmm.
arranged. Okay, these are called domains. Small magnet. These are called domains. But once they are inside the magnetic field, this this iron bar is inside the magnetic field. What is done? All these tiny magnets are aligned in the same direction. All the tiny magnets, they have the same direction. Okay, this way. Then they are behaving like magnets. Do you understand?
Yes.
So, for this reason, we are using the magnetic material for the screening, magnetic screening. Screening means these lines, the field lines can go through them by making the domains aligned in the same direction. Okay, but they
Hmm.
are not affecting the object inside the box. Is
Hmm.
it clear?
Yes.
And uh, why we are using iron? Why we are using soft magnetic material? Because these magnetic field lines, once they are going through this uh, iron uh, iron box, that time they are behaving like magnet. But once these magnetic fields and lines are not available there, then they are behaving like normally, like before, right? Soft magnetic material, isn't it?
Hmm.
But if we are
Hmm.
keeping one steel box over there or cobalt or nickel one, then this one will become permanent magnet. Once it is becoming permanent magnet, it cannot channel the all these magnetic field lines the way the soft iron can channel. Is it
Hmm.
clear?
Yes. Yeah.
That's why we are using iron or soft magnetic material for making these kinds of box for magnetic spinning. So that's why you see in the learning outcomes is to explain the choice of material for and use of magnetic screen. So for magnetic screening, what type of material we are using? Soft,
Software.
soft magnetic material. In your question, sometimes it will come iron or soft magnetic material. Then you will choose iron or soft magnetic material. Is it clear now?
So which one? Iron or soft magnetic material? Either
Same,
one.
same. Anyone. In some MCQs they will mention iron. In some question they will mention soft magnetic material. Okay. If they are giving you iron, beside that they will give you steel, cobalt, nickel, right? If they are giving you soft magnetic material, with that they will give you hard magnetic material. Is it clear now?
Yes.
Okay. Now you wrote magnetic screening, right?
Hmm.
Now you draw this diagram, please. This note is not available in your book. Okay, you give
So
here.
what about the definition?
This one is iron or soft magnetic material. This box,
Hmm.
you draw two layer of this box. This is one inside layer and this is outer layer. And these are magnetic field lines from external magnetic field. Is it clear?
Hmm.
So these field lines are channeled through this iron box, and this one is delicate electronic equipments.
Hmm.
You are right, please. Delicate electronic equipments. You write delicate electronics. That's it.
It's yeah, 1 minute.
So you did not have this idea about domain before.
No, sir.
Oh, these are available also in your book. Domain, about domain. There should be in your book. Let me check. Are this available or not? In checkpoint science book they are available. You see page number 335, figure 21.13.
Hmm.
Page number 335. You see an unmagnetized bar. You see the domains are
Hmm.
not arranged properly. And figure
Hmm.
21.12, a magnetized bar.
Hmm.
So these small arrows are showing you the tiny magnets. These are called domains.
Hmm.
The description is also here available. Theory of magnetism.
Hmm. Yes, I got it. Sir, what about the uses of magnetic screening?
Okay, the use of magnetic screening is to save the delicate electronics from the external magnetic field.
Used to save.
Yeah, save or protect.
Hmm. Used to protect.
delicate electronics from external magnetic field.
External magnetic field. There, this has only one use.
Yes, that's it. Only this one.
And what was the choice of material for iron, right? Yeah.
Yes, iron or soft magnetic material. That's it.
So iron, soft, magnetic material. So what if it was written temporary magnet?
Sorry.
What if it was written temporary magnets, like in
If
the MCQ?
you better give soft magnetic material. Temporary magnet means it's already magnet. Okay.
Hmm.
We are having their soft magnetic material. That one is working as temporary magnet when there is magnetic field closer to it. But we are not using temporary magnet.
Hmm.
Now,
Yes, sir.
now the last part. That is, uh, you just write one sentence that magnetic materials are used in computer hard disk drive for memory. Can you, yeah,
Yes, sir. Then
what you wrote?
I wrote that it is magnetic materials are used in hard disk drive for memory.
Yes, that's, you see page number 343.
Hmm.
It's in at the top. Other uses of permanent magnets.
Hmm.
Other uses of permanent magnets. There you see B. Some computers use small ring magnets as a magnetic memory. Did you write it before?
No,
So this line also you write.
they use it as a magnetic memory. Hmm.
Then you beside it, though now computer is not working like that, but this idea is very close. In computer memory, we are using the disk nowadays, right? And
Hmm.
also for the uh, video and audio recorders, we are now using the disk CD drive,
Hmm.
right? So
Hmm.
previously we were using tapes, right? Video and
Hmm.
audio tapes.
Hmm.
Those video and audio tapes working the principle with the principle, the hard disk or the CD, they are also working a quite similar way. That's why we better to write also those ideas with audio and video tapes. Can you see page number 343, audio and video tapes? It's written there.
Hmm.
Uh, you see, the audio and video tapes are synthetic tapes coated with a layer of ferromagnetic material. Then the recording
So what is
involves magnetizing the tape with an electromagnet. Okay. Sound or
ferromagnet?
sound or picture is represented in electrical forms as varying currents. Here we are using uh, you see the sound or picture is represented in electrical forms as varying currents.
Sir,
In,
sir,
in CD drive we are using light to detect these recordings or to rescue these recordings from there.
sir.
Yes,
What is a ferromagnetic material?
ferromagnetic material means the iron one is called ferromagnetic material. Okay, comes from ferrous. Ferrous is iron, right?
Hmm. It,
So the magnetic material which are coming from iron, those are called ferromagnetic materials.
hmm. Mm, okay. Hmm.
So is it clear now?
Yes, sir.
So this topic is done, right?
Hmm. So what about the worksheet?
Worksheet I will upload now, huh? Then
Hmm.
you try it, and on Tuesday you want to take the test, right?
Yes, on nuclear radioactivity.
Yeah, on nuclear physics.
Hmm.
No problem. So that's all for today, right?
Yes. Okay, sir.
Allah Hafiz.
Allah Hafiz, sir.